अच्छा, मैं एक मिनट अभी आपसे एक चीज और मैं जानना चाहूंगा। मैं अपना कैमरा तो खैर ऑफ रखूंगा, वीडियो ऑफ। Now please inform me, I'm writing something, so can you see or not? Please inform me.
Yes, sir.
Yes, sir.
Yes, sir.
Is it visible?
Yes, sir.
Yes.
Okay, thank you, thank you, thank you. Good evening to all. Today my lecture on discriminant analysis. So first of all, we will understand the concept of discriminant analysis. So as we know, there are two types of research. One is we can divide our research approaches. One is quantitative research and another qualitative research. Okay, quantitative and qualitative research. So we analyze data in quantitative research in, and our data in terms, we can express our data in terms of numeric data, and in a qualitative research our data in the form of words or text. Okay, words. If I ask you, what do you think about the new education policy? What do you think about the new education policy 2020? Describe in 100 words. So you are giving your opinion in 100 words. It is open-ended questions. So we use open-ended questions in qualitative research, but in a quantitative research we use multiple choice questions. Same question I can ask in quantitative research. Do you like new education policy? Do you like new education policy 2020? And there are two options. One is you may uh, like this policy, or you may dislike this policy. If you are like, you can tick yes. If you do not like, then you can tick no. So in a quantitative research, we use clause-ended questions. Researcher give options in advance, but in a qualitative research, here respondent write the answer of the particular question in an open-ended form. So in a quantitative research, we use all statistical tools and technique. We use all statistical tools or technique in quantitative research. Means we can analyze our data, quantitative data, one sample t-test, one sample median test, and the independent t-test, pair test, ANOVA, repeated measures ANOVA, a chi-square test, Friedman ANOVA, correlation regression, factor analysis, cluster analysis, discriminant analysis. It means all statistical tools and technique can be used in only and only in quantitative research. We do not use any statistical tools or technique in qualitative research. So the analysis of qualitative research is different from the quantitative research. We do not use any statistics in qualitative research. So this is a big difference in a qualitative and quantitative research. Now we can analyze our quantitative data through the univariate technique. We can apply bivariate technique, and third, we can apply multivariate technique. To analyze our data. Okay, so today our focus on multivariate technique. Univariate means we are analyzing only one variable, one dv, one dependent variable. And in a bivariate, there are two variable, y dependent variable and x independent variable. So here we are analyzing two variables. But in a multiple regression multivariate technique, we analyze more than two variables at a time. and there may be one dependent variable and several independent variable, or one independent variable and several dependent variable, or several dependent variable and several independent variables. So there are many permutation combination in a multivariate technique. Now multivariate technique can be divided into the two parts. The first is dependence technique and second is interdependence technique. Can anybody tell me the difference between the dependence and interdependence technique? Would you like to explain? Anybody who would like to differentiate between the the dependence and interdependence technique? Anybody would like to explain the dependence and interdependence technique? The difference between the dependence and
Interdependence variables are not classified. Here we are in interdependence, we have to classify the variables. The variables are not classified in interdependence.
yes, absolutely right. Anybody? Anybody who would like to tell about the dependence and interdependence technique? Okay, you're absolutely right, Dr. Abhishek. So in a dependence technique, we classify dependent and independent variable. In a interdependence technique, we do not classify dependent and independent variable. What does it mean? Here we when we analyze our multivariate data through dependence technique, then we classify dependent and independent variable. For example, in a multiple regression analysis, so we classify our dependent, this is our dependent variable y, and we also uh, classify our independent variables like x1, beta 2, x2, other independent variable, beta 3, x3, and epsilon. Okay. Now in this equation, in this model, it's a multiple regression analysis. So here y dependent variable and x1, x2, x3 all are independent variables. Independent variables. And here the purpose of dependence technique to find out the relationship between independent and dependent variables. To find out the relationship between dependent and dependent and independent variables. So here we find or estimate the relationship between dependent and independent variable. For example, y, that is sales. Sales is a dependent variable. Sales may depend on advertising expenses. Sales may depend on sales promotion, means discount. Sales may depend on availability of the product, and there are some other variables also influence sales. I'm taking only 3 variables. You can take 5, 4, 6, 8. Now here we want to find, in a dependence technique, we want to find out the relationship between advertising expenses and sales. So we know that sales dependent variable and advertising expenses independent variable. As we increase the advertising expenses, sales also increase. Here our advertising expenses 1 lakh rupees, when we and the sale is 10 lakh. When we increase the advertising expenses 2 lakh, then sale maybe 25 lakhs. It means there is a positive correlation between the advertising expenses and sales. And as well as we can test our hypothesis also. Hypothesis. So we can create our hypothesis, null hypothesis, and alternate hypothesis. In a null hypothesis, we assume there is no relationship between the advertising expenses and sales, or we can say there is no significant relationship between advertising expenses and sales. But in an alternate hypothesis, it is opposite of null hypothesis. Here we assume there is a significant impact of advertising expenses on sales. As we increase advertising expenses, sales also increase. When we increase advertising expenses, naturally people will be aware about the product or services and they may buy the product. So there is a positive correlation. So we can find in a dependence relationship, we can find the relationship between the independent and dependent variable, and as well as we can test our hypothesis. For example, we are taking many independent variables, means 5 or 6, like a beta 0 plus beta 1x1 plus beta 2x2 plus beta 3x3 plus beta 4x4 plus beta 5x5. Okay, I'm taking 5 independent variables. I'm taking here 5 independent variables. Okay, take 5 independent variables. So this y dependent variable and all x1, x2, x3, x4, x5 are independent variables. All are independent variables, x1, x2. So when we apply the multiple regression analysis to check the impact of several independent variables on dependent variables, then we find out of the 5 independent variables, only 3 independent variables are significantly contributing to dependent variable, and the other 2 variables are not significantly contributing to dependent variable. Significant means, if I say in a private sector there is a the male and female. So here I can develop the hypothesis. I'm saying my statement, there is hello. Is it visible now?
Yes, sir. Now it's
ओके
visible.
ओके। अच्छा, कितनी देर सिनेमा कितनी देर हो गई थी मुझे डिस्कनेक्ट हुआ?
Sir, around 2-3 minutes. You were the last thing we heard was estimating.
अच्छा, मुझे ये बताओ कहाँ से, ये देखिए मैंने एक्सप्लेन किया, ये the out of the 5 independent variables only 3 independent variables are significantly contributing, ये मैंने बता दिया था।
Sir, this time your voice had got cut. This
हेलो,
wasn't properly. This. हाँ, ये नहीं,
ओके, मैं
ये
दोबारा से
नहीं
रिपीट
सुने
कर
थे
रहा हूँ, नो
सर, ये
प्रॉब्लम।
एक्सप्लेनेशन नहीं सुने थे।
ओके,
हाँ,
आई एम रिपीटिंग अगेन, नो प्रॉब्लम। For example, I am taking 5 independent variables and 1 dependent variables. Okay, so out of the 5 independent variables, only 3 independent variables are significantly contributing to dependent variable y. Okay, now the 3 out of the 5, only 3 are significantly contributing. So our beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x, and both the independent variable x4 and x5 are not significantly contributing to dependent variable. Okay, अब देखिए, my purpose to explain the multiple regression analysis, to tell you the out of the 5 independent variables, only 3 independent variables are significantly contributing to dependent variables. Okay, and the 2 independent variables are not significantly contribute to dependent variable. And we can test hypothesis also. Now I am telling you what does mean of the significant. Significant means, if I am saying, देखिए मुझे आप बताते भी रहिएगा अगर आप क्लियर मेरी वॉइस सुन पा रहे हैं, ठीक है, मुझे फोन कर दीजिएगा। वैसे डॉक्टर साहब ने मुझे फोन कर दिया था, तो हाँ, चलिए मैं फिर से इसको, ठीक है, मैं दोबारा से एक्सप्लेन कर देता हूँ इसको, कोई प्रॉब्लम नहीं है। Now in a multiple regression analysis, the one dependent variable and several independent variable, I am taking 5 independent variables b1 b2 beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus beta 5 x5 and epsilon. Epsilon means unexplained term, and all are explained term. So I'm taking 5 independent variables. So in a multiple regression analysis, we can check how many independent variables are significantly influencing the dependent variable y. Okay, so y is dependent variable. So the out of the 5 independent variables, only 3 independent variables significantly contributing to dependent variable. So my final model would be beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. This is my main model. Okay, now we can test hypothesis here. The out of the 5, only 3, we can test 3 hypotheses, means the only 3 independent variables are giving significantly result. So significantly means, if I compare the salary of male teachers and salary of female teachers in private sector, so the male teacher salary is 50,000 and the female teacher salary is 48,000. This is one condition. Another condition, 50,000 and 45,000. And third condition, 50,000 and 40,000. So out of the 3, we can see this difference is significant. Significant means more difference, significant difference. This is significant difference. 10,000 rupees, significant. So in a dependence technique, we can test our hypothesis, and as well as we can check the how many independent variables are significantly contributing to dependent variable. And the condition is, in the multiple regression analysis, the condition is the all the variables, whether dependent or independent, all the variables should be metric. This is the condition. So basically there are two types of variables, metric and non-metric data. Non-metric means if we are preparing our questions in nominal or ordinal, it is known as non-metric. Metric means if we are preparing our questions either interval or ratio, then it is known as the metric data, metric. So condition of multiple regression analysis, all the variables, whether dependent or independent, all the variables should be metric, means we should prepare our questions in a either interval or ratio scale. But in an interdependence technique, now the difference with the other technique, the interdependence technique. In a dependence technique, we discriminate. In a dependence technique, we discriminate dependent and independent variable. And through literature review, we identify this one dependent variable and these are independent variables. But in an interdependence technique, we do not discriminate, or we do not segregate dependent and independent variable. Simultaneously, we take all the variables and analyze. And the purpose of interdependence technique to creating the group, or factors or segment. Here we do not test the hypothesis in interdependence technique, and we do not find the relationship between independent and dependent variable, like exploratory factor analysis. What is exploratory factor analysis? It is data reduction technique. Data reduction, the purpose of exploratory factor analysis, data reduction and summarization. Okay, this is the purpose. We take a large number of questions, like 50 questions, and then apply EFA, and after EFA we obtain 20 relevant questions, and then we club same nature of questions and make the factor, like factor 1, factor 2, factor 3, factor 4. We club 4 or 5 questions. So here we create the factors or a group or a segment. Like in cluster analysis, we create many segments, many clusters: cluster 1, cluster 2, cluster 3, cluster 4. For example, in a shopping mall, the buyers, all buyers are different, means the heterogeneous type of buyers. Now we can club same nature of buyers, like some people want to enjoy buying product or eating food and see the movie. So we can say enjoy loving buyers. Some people want to buy only the discounted product, so we can give the name economy buyer. Some people they don't take enjoy in eating food, watching movie or buying product. They buy the daily need product, so we can say passive buyers. So the purpose of interdependence technique to create the cluster or segment. Now I come to the discriminant analysis. What is discriminant analysis? In a multiple regression analysis, all the variables should be metric. It's a prediction technique. We can predict outcome variable on the basis of several independent variable. And discriminant analysis also predictive technique. We can predict outcome variable on the basis of several independent variable. But the difference of multiple regression analysis and discriminant analysis is, here in a discriminant analysis, the outcome variable, the non-metric, means the dependent variable, non-metric means nominal type questions, and all the independent variables, metric data, means we created or we prepared our all the questions in the form of either interval or ratio. Metric means the our questions either interval or ratio. Non-metric means categorical data like male, female, rural, urban. There are two mutually exclusive categories. So in a discriminant analysis, we can predict our outcome variable on the basis of several independent variables. Whether the particular buyer will buy the product or not buy the product. So we can divide our buyers into two categories. We can classify our respondent into two categories. Same as we can classify our outcome variable like a successful employee or unsuccessful employee on the basis of several independent variables. And independent variables may be sincerity, may be the one reason, and the timing, and the third variable may be the he can do the the जो work allotted है वो उसको कर ले timely properly. So there are many independent variables like whether the particular employee, teacher, treated as successful teacher or unsuccessful teacher. So on the basis of several independent variables, if he is writing the research paper in ABDC journals, ABDC, if his paper published in ABDC journal, or he also the classroom teaching also good, and he is very sincere. So there are many independent variable. On the many independent variable, we can say the particular teacher successful or unsuccessful. Every teacher will get the discriminant score above. For example, the discriminant score of teacher number 1 is the 2.5. So it is above the 2. We can treat him as a successful teacher. If someone getting 1.3 discriminant score, we will treat him as a unsuccessful teacher. So in the main difference of the multiple regression analysis and discriminant analysis is, in the discriminant analysis, the outcome variable, our dependent variable, nominal. If we divide our outcome variable in two groups, means successful, unsuccessful. So this technique is known as two group discriminant analysis. Two group discriminant analysis. If we divide outcome variables like light user, medium user, and heavy user of the particular product, so we can divide our the buyer into three categories. So when we divide outcome variable into three categories, this is known as three group discriminant analysis. If outcome variable 4, then so generally we use 2 or 3 categories. Okay. So this is the concept of the discriminant analysis. Now you can see the PPT. The multiple regression analysis. Now what is, so every statistical tool and technique has its own assumptions. It means before applying any statistical tool or technique, we should check the assumptions. For example, if I want to apply independent t-test, so before applying independent t-test, I will check whether my data normally distributed or not, whether my data homogeneous or not. Once my assumptions fulfill, then I can apply independent t-test. Otherwise, I will correct my data by using log transformation, square root transformation, inverse root transformation. Still my data not normal, not homogeneous, then equivalent to independent t-test, I can apply non-parametric test, that is the Mann-Whitney U-test. Same as in a multiple regression analysis, it has also some assumptions. So we should check the assumptions also. Now question is, what is multiple discriminant analysis? Multiple discriminant analysis is an appropriate technique when dependent variable is categorical. Dependent variable categorical means nominal, like male, female, rural, urban, private sector, public sector, Kolkata, Chennai. So when dependent variable, this is our dependent variable, when dependent variable categorical, and independent variables are metrics like x1 plus x2, x3, all independent variables, IV, all independent variables in metric form, and this dependent variable non-metric. The single dependent variable can have 2, 3 or more categories. So condition of discriminant analysis, if we want to apply, we want to classify our objects into two mutually exclusive category, then we should prepare two types of question. One is dependent, our dependent variable should be categorical or nominal, and all the independent variables should be metric. Okay. This is equation of multiple discriminant analysis. Here it is same as the multiple regression analysis. Only difference is in a discriminant analysis, our outcome variable, this outcome variable is categorical. Okay. So here equation is ZJK A plus W1. It is regression weight, same as discriminant regression weight. It is discriminant weight. ये देखिए WI means discriminant weight of independent variables. Discriminant उसमें क्या होता है, regression weight in a multiple regression analysis, beta 1, beta 2, beta 3, and standardized regression weight vary from -1 to +1. Okay. Now here the W1, it is same as the regression weight, but here the term we use discriminant weight of independent variable, discriminant weight. Okay. And A intercept and X independent variables. X1 means one independent variable, two independent variable, and so on. So the process of multiple regression analysis, there are 6 stages of multiple regression analysis. The stage 1, objectives. We should define what are the objectives of our research. In the second, research design. So how to collect data, what type of question we should prepare, metric or non-metric, how many questions we should prepare, what should be the sample size. So we will decide all these things in research design. Then assumptions of discriminant analysis. I told you every statistical tool and technique has its own assumptions. So before applying the linear discriminant analysis or multiple discriminant analysis, we should check the assumptions, then estimate the discriminant model and overall fitting, then interpretation of results, and then validation of results. We can divide our sample into two parts, and then we can check the cross validity of the coefficients or the results. Okay. Why should we use discriminant analysis? What is the purpose of the discriminant analysis? Initially, I told you the purpose of a discriminant analysis to classify objects. We classify objects such as individual. We can classify individuals into many categories, firms, products. Okay. So discriminant, the example you can see, we can classify our individual or buyers, heavy users or light users. So company make policy different for heavy users and the light users. So there may be you can give more weightage to your heavy users. The other is purchaser or non-purchaser, whether the particular person will buy the product or not to buy the product. For example, you want to buy the car or bike, okay, and you enter the showroom, and the retailer or the distributor gives some questions. If your answer of the several independent variables the more than this particular cutoff value, then you will purchase the product. If your cutoff value, your score less than the cutoff value, then you will not buy the product. Same as the bank can also divide the clients into two categories: good credit risk or poor credit risk. If you are good credit risk, if you repay good, then you can get more loan. So generally we can classify our data into two or more categories. This is the main objective of the now you can see here there are two types of buyers. The one is A and other is B, and this is overlapping. So if we classify our buyers into two mutually exclusive 100% two mutually exclusive categories, and there is no overlapping, then we can say our model is 100% fit. We can predict 100% our buyers, but no model is 100% fit. Some model may be 90%, some error. Some model can predict 80% correct and 20% not correctly classify the objects. So this is our overlapping, means this overlapping should be less, or theoretically it should be mutually exclusive, completely different from the other. Now, second question you may ask, sir, what should be the sample size for conducting the discriminant analysis? The sample size is 5:1. What does it mean, 5:1? If you are taking 5 variables, you are taking 4 variables, so your sample size should be 5 times of your variables. Your sample size should be 20. If you are taking 10 questions, okay, including dependent and independent variables, your sample size should be 5 times. So the ratio is 5:1. One question, 5 respondent. Two questions, 10 respondent. 5 questions, 25 respondents. 10 questions, 50 respondent. This is the one condition, sample size. Selection of dependent and independent variables. How will we select our independent and independent variable? So we select two types of variable, dependent and as well as independent. But we should keep in mind our dependent variable should be categorical, the non-metric. This outcome variable should be non-metric, categorical. Means outcome variables should be either two or more mutually exclusive categories. And independent variables, all independent variables should be continuous or metric. Continuous means we should prepare our question either interval scale or ratio scale. We should prepare our questions in a metric form or continuous data. Then we can apply the uh, discriminant analysis and we can classify our objects into two mutually exclusive categories. You can see the example of discriminant analysis. Here there are four variables, one dependent variable and three independent variables. So there are four variables. The condition is dependent variable should be non-metric. Variable should be non-metric, categorical. The variable should be dependent variable should be categorical, non-metric means nominal. So here I am taking the question, the dependent variable, whether the particular person would buy the product or not. So I divided my outcome variable into two mutually exclusive category, would purchase or would not purchase. For example, the customers want to buy the bikes, या bike खरीदना चाहते हैं. Then whether the particular person will buy the product or not on the basis of several independent variables. So when you buy the bike or car or any other thing, then you check whether the product durable or not, whether the performance of the product good or not, whether the looking is good or not. So on the basis of these independent variables, you may buy this product or not to buy this product. So we can classify our buyers into two mutually exclusive categories, and we can predict whether the particular person will buy the product or not on the basis of discriminant score. So when the potential buyer enter the showroom and we give the questionnaire and we ask him or her, please fill this questionnaire, give marks of durability out of 100 and marks of performance and looking. So if someone is giving high marks to durability and he or she thinks that the performance is good and looking also good, then there may be possibility his or her discriminant score above this cutting value, above the this discriminant score, cutting score, and he will buy the product. If someone giving less score to the durability, less score for performance, and less score for looking, naturally he will not buy the product. So we can prepare the model, and our this model, this equation known as model, it is our model, and on the basis of this model we can predict whether the particular person would buy the product or not. It is not necessary that our model predict 100%. I told you no model can give 100% result. There may be some error also. If our model is giving 90% correctly specify we can say it's a good fit model. Okay. Now you can see the questions. Durability of the bike 0 to 100 and performance of the bike. We should prepare our question in a ratio scale. इस तरह के क्वेश्चंस होंगे. Sample validation. So we can divide our sample into two categories for validation purpose. 50-50%. 50 means estimated sample 50% and validation 50. Or we can divide our sample into 40 and 60 ratio. 40% estimation and 60% validation. Or 30 to 70 for checking the cross validity of the product. And now for the cross loading, we can for cross validation purpose we can divide our sample into two categories. Now the assumptions of this test, discriminant analysis. So there are four main assumptions of discriminant analysis. The one is data should be normally distributed, linearity, multi-collinearity, and equal variance and covariance matrices or box M score. So we can check the normality, linearity, and multi-collinearity of the data. So linearity means, normality means our data should be in a bell shape. Bell shape means ghanti. Now you can see the bell shape. So the distribution of the data should be in a bell shape. Bell means the ghanti, the mandir mein ghanti hoti hai, temple mein. It's a bell shape. So it is not absolutely in a bell shape, but more or less in a bell shape. We can say data is normal. Second is the linearity. Linearity means the relationship of the dependent and independent variable should be in a straight line. The data should be linear. So it is more or less, not absolutely linear, but it is more or less this PP plot is giving linearity. PP means probability plots. And the third is multi-collinearity. What is multi-collinearity? Basically, multi-collinearity is a issue. It is an issue. For example, this is your multiple regression analysis, beta 1 x1, or you can beta 2 x2, beta 3 x3, and so on. In a multiple regression analysis or any other predictive technique, we want the relationship independent variable. This is x, y, independent variable, and y. Dependent variable should be significant. It should be significant. All the independent variables highly significant with the dependent variable, but the independent variables, the x1 and x2 should be, there should not be any relation, no correlation, or we need x1 and x2 should be unrelated, or zero correlation. Same as x2 and x3 should not be highly related. x1 and x3 should not be highly related. So what is the criteria to find whether my data has multi-collinearity issue or not? So when we take the bivariate correlation of independent variables, all the independent variables should be less than 0.6 correlation. If correlation is less than 0.6, then we can say there is a no issue of multicollinearity. Although the multicollinearity in regression analysis we can find out through VIF and tolerance. Okay, but here we can find the multicollinearity through the find out the correlation of the independent variables. Now the fourth is p-value should be non-significant. Equal variance and covariance matrices should be non-significant. It means the variance and covariance should not be there should be homogeneity in the data. So we can check it through the the box-sum plot. So box-sum score. Through box-sum score we can check whether the equal variance and covariance exist or not. Okay, so these are the assumptions of and after that the fourth stage, estimation of discriminant model and assessing overall fit, stage 4. So we use simultaneous estimation. All independent variables considered concurrently. We can take all the variables simultaneously and analyze the discriminant analysis. And we use stepwise estimation. Stepwise means, so for example, if we are taking in a stepwise, for example, we are taking one dependent variable and three independent variable. Stepwise means in the model one means we are taking only one independent variable and one dependent variable. Model 2 means we are taking two independent variables and one dependent variable. Model 3, we are taking only three independent variables and one independent variable. So we can check it through the stepwise estimation. Now, assessing the overall the discriminant score of each observations or each participant. This is my final model or equation to predict the outcome variable, whether the particular person will buy the product or not. This is my main model. So he will give the rating to the durability. He will give marks out of the 100. If he is giving good marks, 80, 90 for durability, or for good mark for performance and as well as looking, then naturally he would buy the product. If he is giving less mark to the durability, performance and looking, then his discriminant score will be less than this cutting score. Then he would not buy the product. Okay, this is my ये इसके बाद जो है we can check cross validation के लिए हम क्या कर सकते हैं, we can check it whether the results are same for the stepwise and validation. So we can divide our group into two mutually exclusive categories. Now, assessing overall measurement fit. So when we whether my model good or not. So we can check the prediction accuracy. Hit ratio, it's a score. Hit ratio tell us about how much model is good. For the hit ratio score is 84%. It means this model can predict 84% correct and 16% misclassification. Okay, so correctly this model can classify 80%, 84%, and this is our error. So higher the value of hit ratio, model is good fit. Lower the value of the this hit ratio, model not good fit. Now in this example, we took 25 people, actually they will buy the product, but our model is saying out of the 25 only 22 buy the product and 3 will not buy the product. It means our model only 88% correctly classify. Now we took 25 people who would not buy the product. Out of the 25, 20 are not buying the product, only 5 people are buying the product. So this model 80% correctly classify the would not purchasers, and the overall the hit ratio that is 84%. So it's a formula of the hit ratio to calculate, and the answer of this is, now you can see the 84% model is correctly specified. Now this diagram, the cutting score, this is our cutting score, and this one is model overlapping. Overlapping means the less value of overlapping, model is good fit. If the overlapping is more, model is not good fit. Now classification matrices, cutting score determination, cost of misclassification, benchmark for hit ratio, or we use the interpretation of the result. There are 3 methods: standardized, discriminant, weight. Each weight represents the relative contribution of its associated variable to the function. So we can see the value of standardized, canonical, discriminant function coefficient in output table. I will show you. Then discriminant loading, the structure correlation should be greater than 0.3, means W1, W2, W3. All the discriminant loading should be greater than 0.3. Then we can divide our sample into 2 parts for cross validation purpose. So I will use this data set for conducting the discriminant analysis. So we take 5-minute break, and after the 5 minutes we will meet again. Okay.
So can you share this data set so that we can also do practice if possible?
PPT.
No, the PPT and the data set so that we can also do
Yeah,
practice. with
sure, 100%. I will share you.
Okay, doctor.
So I have uploaded 116 videos on YouTube.
Yes,
And all the 116 videos I uploaded my all data set. So
okay, yes.
Even if you do not get here, although I will share to sir my PPT and data set, you can practice it. But if you want to practice, then you can watch my video. And I'm just writing the Dr. Shailesh Kaushal. When you name Dr. Shailesh Kaushal in the YouTube or Google, then you will find my videos, Dr. Shailesh Kaushal. So I'm showing you my video on discriminant analysis. Can you see this? Is it visible to you? My channel name?
Yes.
Yes, sir.
Okay. So I'm showing you the discriminant analysis. but all videos are in Hindi. Yeah, you can see here the discriminant analysis. So I have uploaded my videos data set. You can see here the discriminant analysis. Same example I'm
Okay, sir.
explaining here. Okay, so you can get this data file from my channel also. Hey, here you can see the I have written here links of data set and case study used in this above video. You just uh, the press this button and you can download all the file and data set also. Okay.
All right, sir. Thank you.
ठीक है सर, तो
ठीक है,
5
sir.
मिनट का हम
Thank you.
लोग ब्रेक ले लेते हैं. इज
Okay,
इट
sir.
Sir,
ओके? ओके,
sir, okay, sir. Thank you.
थैंक यू. Hello, can you hear me?
Yes, sir.
हाँ ठीक है, तो हम स्टार्ट कर रहे हैं फिर, ठीक
Yes,
है?
sir. Yes.
ओके ओके ओके, थैंक यू थैंक यू. Now I'm taking a very simple case study to explain the discriminant, two group discriminant analysis. In this case study, we want to predict whether the particular person buy the bike or not. So from the literature review, we found the buyer give weightage to durability when they buy the product, they give weightage to performance, and they give weightage to looking also. So out of the three, there may be durability may be more important feature to the buyers than performance and looking. There may be possibility looking will be less important factor for this model. So we collected data of 80 respondents, and I divided this data set into two groups: 40 sample size for estimation purpose and 40 sample size for validation purpose, for checking the cross validity, whether the results are same for the two sample or different. If results are same for both the sample, estimation and validation sample, then we can say our result is good, there is no problem. So I have divided this group into two mutually exclusive category, and I divided this sample into two group. This here you can see the estimation sample. So for estimation sample, estimation purpose, we took 40 buyers, and in a 40 buyers, out of the 40 buyers, we took 20 purchaser and 20 not purchaser. 20 buyers, 20 respondent buy the product, and 20 person not buy the product. So out of the 40, 20 buy the product and 20 people will not buy the product. Same as in a validation sample, we took 40 people, and out of the 40, 20 people will buy the product and 20 people will not, would not buy the product. Okay, this is my data set. In this data set, there are three independent variables: durability. The respondent number one give 76 marks to the durability and 84 marks to the performance and 58 marks to the looking. So we will predict whether this particular person will buy the product or not. Other sample, this 21 respondent, this respondent will not buy the product, and you can see the score of this person. He is giving 48 marks to the durability, 39 according to him performance is not good of the bike, and he is giving 68 marks to the looking. He thinks the bike is good looking, but durable according to him, the product is not durable or less durable, not good performance. That is why he is giving low score for durability and performance. Okay, this is my data set. Now I am performing the discriminant analysis. So I divided my sample into two mutually exclusive categories: estimation and the estimation and validation. So I am dividing I'm splitting this file into two categories. So how to split this file? Go to data, split file. I'm splitting 40 sample size, 80 sample size into two mutually exclusive group. One is estimation and second is validation. So here go to data, split file, then compare groups and sample statistics, and then transfer into this box, and then okay. Now my sample has been splitted. Now you can see the lower right hand corner. Here written is sample, so split by 50-50. Okay. Now I am applying the two group discriminant analysis. Two group, go to analyze, go to analyze, then analyze, classify, and discriminant. Analyze, classify, discriminant. Then transfer potential buyers. It is categorical. There are two categories: would buy, would not buy. So it is dependent variable, grouping variable. I am transferring here grouping variable. And define range 1 and 2. We have coded 1 for would purchase, 2 coding for would not purchase, and then continue. Now select all the 3 independent variables: durability, performance, and looking of the bikes, and transfer into the independents. And here use, tick this button, use stepwise method, because stepwise method will give us 3 models. Model 1 means when we are taking one dependent and one independent variables. Model 2, one dependent and 2 independent variables. Model 3, one dependent and 3 independent variables. So here use stepwise method. And then statistics. Means, tick univariate ANOVA, tick box M, Fishers, unstandardized, then matrices within group correlation, tick within group covariance, separate group covariance, and then continue. After continue, press this button, method. Method by default Wilks lambda. We do not need to change anything, just press this button, continue, then classify. Here you can see the display. You tick this button, case wise results, summary table, and then you can this combined group, plot, separate, territorial map, and then continue. And then okay. Now you can see the total sample size. We divided into 2 parts: estimation sample 40 and validation sample 40. Now we check the group statistics. In a group statistics, you can see the people who are buying the product, this one, the 40 sample size estimation sample and 40 sample size validation. So it is not necessary you divide your sample into two categories. Directly you can estimate your sample also. You can directly analyze your 80 sample size. But theoretically or ideally, we should divide our sample into two parts for checking the cross validity, for validation purpose, whether the result of estimation and validation same or not. Anyway, now for estimation sample, the purchaser, the sample size is 40, and we took 20 people purchaser, and 20 people would not purchase the product. Those who are purchasing this bike, their mean score for the question number 1, 69 mean. And those who are not buying the product, their mean score for the durability 31.3. It is very significant, very big difference. For performance of the bike, the score is 67.65, and those who are not buying the bike, they are giving less score, mean score 45. Again, it is significant. Third, for looking of the bike, those who are buying the bike 39.30, and those who are not buying the bike score is 40. So both the groups, whether they are purchaser or not purchaser, they are giving less score for looking. So according to them, looking is not important, only durability and performance may be the important features of the bike. Same as you can validate the 73 and would not purchase, here 30. Again, it is a big difference. 66 and 44, big difference. But here 39 and 36, not a big difference. The results same more or less for estimation and validation. Now after that, I come to the second table. Now you can see the test of equality of group means. So in this table, the estimation sample, durability of the bike significant, performance significant, but looking of the bike is not much significant because p value is greater than 0.05, 0.745. So according to this, the looking of the bike is not good. Now you can check the correlation among the three independent variable: durability, performance, and looking. Covariance, the correlation is standardized form of covariance. Correlation value always will vary from -1 to +1, but covariance value may be infinite. So I am interpreting this table through correlation matrix. Now you can see the performance of the bike and durability 0.153, looking of the bike 0.398, and performance of the bike and looking 0.13. Now here you can see there is no issue of multi-collinearity because all the three independent variables are less than the 0.6. Now you can see the significant, the p value for estimation, it is result is good, 0.06. Boxem plot, Boxem score is non-significant, but here it is for validation, it is less, it is not good. Now in stepwise, the main, where is main table? Split estimation, and yes, the durability, canonical, we need canonical discriminant function. Yes, this is my main equation. So there are many tables. All tables need not require for our interpretation purpose. We do not take only tables. So here I am taking the main model. Now what is our main model? We will take our model, showing you the results. Yes, this is my main model, and in this model you can see the results of the estimation sample. This is my main model. Yes, this one. This is main model. So here Z equal to minus 3.021, it is intercept, plus durability. And what is the discriminant weight? Durability minus 0.056 into durability plus performance 0.026 into performance minus 0.030 into looking. So this is my main model. Now you can put the value of the durability, value of the performance and looking, then you will get the discriminant score of individual, discriminant score score of individual person, and as well as we will get the cutting score. How will we get the cutting score? From which table? This is my cutting score. Centroid, group centroid. This is cutting score. Cutting score is this. The range is minus 1.36. This is 0, and the value is minus 1.365, and this is plus 1.365. So the people whose score is positive, they will buy this product, and the people whose discriminant score negative and less than 0, they will not buy the product. So the 0, the positive value, they will buy the project. Negative value, they will not buy the product. Okay, so we will check it, and then this is my how correctly my model good. This now you can see the classification result. So here we will get the hit ratio. For hit ratio, we have taken 20 people who purchased the product. Here you can see how much my model is fit. We took 20 people who will buy the product. Out of the 20 people, my model is saying 18 people will buy the product and 2 people will not buy the product. Okay, if we take it in percentage, my model is fit 90%. And would not purchase, my model is saying we took 20 people, out of the 18 would not purchase and 2 are purchasing the product. Again 90%. So here the model is we can say the 90% originally group correctly classify. Hit ratio here, 90%. My model 90% correctly correctly classify the particular person, correctly correctly, I should say, my model correctly fit. ठीक है, अभी देखिए. Now there are two person, they would not purchase, they are not purchasing, even they buy the product, but my model is saying they will not buy the product. Now you can see this table, case wise statistics. In the person one, actual one means one coding means buy the product, and predicted group, the person one is buying the product and my model is saying yes, he will buy the product. Now you can see here the respondent number 16, actually he will buy the product, but my model is saying he will not buy the product. It means it's a misclassification. Same as respondent number 17, he buy the product actually, but my model is saying he will not buy the product. Same as those who are not buying the product, but here the case number 24, my model is saying he will buy the product. So there are two cases here, 33 and 24. My model is not correctly classified them. So my model is only 90% fit. 90% fit. Now you can see the results. Okay. We can save the results also here. Go to analyze. Classify, discriminant, and save the predicted group membership, discriminant score, probability of group membership, and then continue. After continue, you can save the score of all the 80. Yes. Now you can see the discriminant, purchase. Okay. Now there are group. So here you can see the respondent number 16. Actually he would buy the product, but my model is saying he will not buy the product. So it's a misclassification. 16 and 17, because value is negative, less than 0. And same as the would not purchase, there are two cases, the case number 24 and case number 33. Case number 33, my model is not correctly classified two cases, because the would not purchaser value should be minus, but my model is saying 0.1435, cutting value above 0, which is not desirable. So this is all about the discriminant analysis. Thank you very much. Now you can ask any query if you have any query.
Sir, can you tell us about that canonical discriminant function coefficient? There are two sample. One is estimation sample and